happy to be here. Super happy that I'm allowed to talk about event sourcing. For me, that is a very fascinating way to build business solutions. But much more important, it's actually a very useful way to build business application for the right problems to solve. I've been in the software industry for a very long time, and the last years I've been into the DDD community. And there I learned about event sourcing. And these days I'm a hands-on coding architect in a team in Equinor. It's an energy solution company in Norway where I work. And there I'm allowed to do domain-driven design together with behavior-driven development to build event-sourced business applications. But today it will be all about event sourcing. But before I go into the details of event sourcing, I want to put it into context with event-driven architectures. If you have an event-driven architecture, you typically have a solution that publishes some events, and we call them outside events, or integration events, or external events. It's events between solutions. And you have other solutions that subscribe to those events. And of course, the one that publishes an event can, and typically will, also subscribe to an event. So that event-driven architecture, event sourcing on the other hand, it's all about inside one solution. So this is not a high-level pattern. This is nothing you go home and say, oh, we will do event sourcing every place now. It's a pattern inside a solution or part of a solution. And there we have what we call internal events. It's the internal of the solution. And when you do event sourcing with domain-driven design in mind, that we do, we want to model those events as domain events. And domain events is something that has happened, so it's a fact, that the business cares about. And that helps us to model those events on the right level. And these events, the domain events, live in our event store, and as I say, inside one solution. So that's the difference there. But event sourcing and event-driven architecture really plays very well together, but you don't have to do the one to do the other. You can have event sourcing in a completely REST-based architecture, and you probably would have a combination of those kind of patterns. So, what is event sourcing? Well, for short, it's a mature way of thinking. It is what accounting has done for hundreds of years. And it's actually what GitHub is doing every day. And even in the info queue, here I show the report from last year, both event-driven architectures and event sourcing is in the late majority. So I think it's a mature choice to take, again, if you have the right problem to solve. I will introduce event sourcing by using a shopping cart. That's a typical way to do it, so I will do it that way too. When I did non-event source solution, I would probably have some tables somewhere, and I would have a cart table and some cart items table, and I store the state. But if you think about it a bit differently, how did we get to that state? Well, an item was added, another item was added. Domain events again. And this is like my husband is shopping. Adding one, adding another one, checking out, structured, to the point. Me shopping, on the other hand, I add an item, and then I add one more, and then I remove one. All these choices, and I add a new one. But I could actually get to the same state. And this more path leading up to the same state, I will come back to later. And the point here is that I can, at any point in time, I can loop through my events, and I can source the state from those events, hence the term event sourcing. And you can say you source the state from the only source of truth when it comes to data in your solution, in an event source solution, because that is your events. And now I will pause a bit, and I will talk about aggregate. That is a concept from domain-driven design that I find really valuable or useful when I do event sourcing. So if you haven't heard about aggregate, you can think about it as a collection of business entities with both behavior and data. A shopping cart is a typical example of an aggregate. A customer could be an aggregate. A product catalog could be an aggregate. So why do I want to introduce you to this concept? Well, if you were thinking about all these events, and there's no tables, it's just an event store. My information has a home anymore. It's just flying around like events everywhere. Well, it isn't. The home of your events is in a stream, and that stream belongs to the instance of an aggregate. And in DDD, when we do have an aggregate, it will always have an ID. So the events belong to a stream, and the stream belongs to an instance of an aggregate and tells the story of that one. The other thing, the reason why I wanted to introduce you to aggregate, is that when the user does something in the user interface, we want to capture that intention into a command, and that command has to do something to something. Whatever should it do something to? Again, it's the aggregate. And this could lead to new event that is appended in the end of the stream of the events for that aggregate instance. And the sequence of these events are critical. I guess you all can see that. Try to start with removing an item. Things will be messy. And that's all it is. So maybe I can just end this presentation now. Event sourcing is all about storing those events instead of storing your states. It's a new way to save your information. But for me, it's much more than that. Why is that? Well, this way of storing information has some consequences. And here, when we want to display an order summary, for instance, or a product list to the users, and we don't only have the events on one side, how do we go about there? Here is a pattern, command, query, responsibility segregation. That comes in very handy. It splits the write side, where you create your data, with the read side, where you ask for information from your data. And it's not like you try to make one big read model. Actually, you try to make small and specific read models. And we have a projector. And a projector listens to the events. But the projector is allowed to listen to events for all aggregate types and all aggregate instances. It listens to all your events in your solution. And it can just pick out those events it's interested in, and the details inside that event it's interested in, and it builds up this state. And as I said, not one big one, many small ones, so we can throw it away if it's not of relevance anymore, and we can make a new one when the users need to see something more information, or needs a new report. And then, when we have these events, we have an opportunity. We can do as we do in an event-driven architecture between solutions, but inside of a solution, we can start reacting to these events. And here comes the concept of reactors in handy. And when you have a lot of automation in your solution, there is a lot of those rules, whenever this happens, that should happen. The reactors is the ones that take care of that. So again, you have an event, and you capture the intention for how you want to react to that event into a command that can do something to aggregate, or it could also perform side effects like API calls or sending emails. And reactors is the only one in our solution that do this part. And reactors help us with a more event-driven architecture inside of a solution, because one aggregate can have its reactor and react to what has happened in another aggregate, but also between solutions. But I said, event sourcing, events are internal. Sharing is not caring in this setting. You shouldn't share them, but you can react to them and then make an outside or integration event that you share with the rest of the world. And you can react to them to make those API calls you need. Anyone figure out that I like event sourcing by now? Well, I think the reactors is the cool stuff, and there's a lot of power there. And we've taken an example for the solution I'm working on now. Okay, when they use a certain strategy, because the traders can make some digital strategies, and that should end up with starting an algo on a third-party platform. Well, then the strategy aggregate has its responsibility, and it emits a strategy started event. And then the product recommendation that holds a lot of recommendation for a product, it can listen to it and say, oh, a strategy that I'm interested in has started. And it make a lot of algo-enabled events for those recommendations. And then the algo handler can be the one responsibility to actually start that algo on the third-party platform. So we have these reactors that can lead to kind of a domino effect. I already said this, event-driven architecture inside our solution too, with these reactors. But there are more consequences. I don't have the state anymore. So How do we correct mistake? Another thing I like with event sourcing is that it really is mimicking the real world. And just think about it. If you go to Las Vegas, you have a really nice evening, and you get married, and next day you wake up, and you regret it so much. What do you do about it? I think you should do some compensating action. Maybe try to cancel that marriage, so you get a marriage cancelled event. And that event will for always be a part of your story. And the same what accounting is doing. If it's a fat finger mistake and you pay 1,000 instead of 100, they don't just update that number. The correct mistake might be by crediting the whole amount, and then you pay the right amount. So you have some compensating events, and those events in our solution will be part of the story of the aggregate instance, and it will forever tell the story more truthfully than if you just updated the state. And when it comes to business rules, I feel that event sourcing gives me a better toolbox than I had for my non-event source solution, because I have different places to place different types of business rules. This writing with command when a user does something in the interface that is really similar to what it was before. If it's a calculation, there's a lot of business rules the calculation needs to take care of. And it also needs to take care of validation. Is that user allowed to do that calculation? And what we in DDD calls invariance is all the rules that need to be saved at rest. For accounting, it could be that sum debit have to be equal sum credit. So all that the writing with command take care of. And then you have the reactors that I already mentioned. Whenever this happens, that should happen. And the more automation we put into our solution, more of these rules. It's so good to have a reactor that really can own them. And if the reactors do something to aggregate, it needs to take care of validation and invariance too. And then you have the read side and the read models. And that take care of all the rules related to transforming the data. It doesn't make any new data, but just transform it and put it together differently. And you can say, there's not much business rules there, you just put some data together. Well, my experience is completely different, because some heavy dashboard we have is all about transforming this data. And there's a lot of rules from details like how many digits should you use in a calculation to how should you group things if you have a product catalog, for instance. All those rules are now living into the read side and don't have to be put into the write side. So since we have more places to solve the problem, each problem tends to be smaller. And that is something I like with this toolbox. So a bit summary on what is event sorting. Well, you have this, that the user does something in the user interface, and that it does something to the domain model where the aggregate lives, and then the events are saved. And when the user interface needs some information, it has a query handler. But it's not like the read model. Wait until someone asks for the information to build up this read model state. It always listens real time, or near real time as possible, and build it up so it's already there when the user interface needs this information. And then we also have the reactors. So that is about what is event sourcing. And then we can go on to why should you use event sourcing? And that is an easy answer to give. You should only use it if it fits the problem to solve. But even that is the right answer. And I think it's an important one, because this way of building solution, even though I love it so much, I think that's because I have some right problems to solve. It's not something you should do for every project. It's not something that you should always do. But I think this easy answer don't help you much. So what I will do now is to try to go through some good parts. The gain with doing this way, building a solution this way. And then some hard part, the pain of building business solution this way. And then you can see, you should probably use it if the gain is bigger than the pain. And one of the, should I say, mantras when it comes to what is so good with event sourcing is that we never lose any data. And here I come back to these two different paths that lead to the same state. If you only have saved a state here, and someone asks for a report for how often are these kind of shoes removed from the shopping cart, You don't have that information. So that is what they mean by never losing any data, because we just save new events all the time. So we never update our information, and by that losing data. But I've been working with business solutions for years and years. And was it like we were losing data all the time, just kind of throwing it away and we didn't know what had happened? For me, in our solution, that wasn't what was happening. But I needed to add information to my aggregate. We added versioning. And then we added a flag, so we knew that, okay, this information has been saved after a user calculated something and then just saved it. But this information was saved after a user calculated, updated, and saved it. And then we had the sysub user into the user column that tells us that this was triggered by another solution. And after I started to do event sourcing, it had kind of realized, why did we do that? Because it cluttered my aggregate back then, so I didn't like it, but I need to have it there. It's actually because we wanted to know how we got to that state. Voila! Do event sourcing, and you get it for free. Well, there is nothing as a free lunch. We all know that. It has a caveat, this way of doing it, but at least this part, knowing how to get to the state, that is kind of inbuilt and easy to get without needing to clutter some information in an aggregate. But that was what we did before. So it wasn't that we were losing data, but it was not so easy to take care of all that data without messing up our domain model. And then I have this phrase, architecting for tomorrow's question. Because Equinor wants to be a data-driven organization. And I guess a lot of organizations wants to be that these days. And then someone will, and they should, I think, ask me a new question tomorrow. Could you answer this one, or could you show us this information? Then we need to have that information. And what we do is that we keep all the relevant information related to each event. And that's much easier than having an aggregate with all the relevant information, because that's so huge. But an event, it's something that has happened that the business cares about. That is something I can discuss with my business. I can really understand what information is of relevant of just this event. It doesn't need to know anything about the events before and the events after. But I can put that information into the event without cluttering the rest of the solution, without making my read models very hard, and so on. And then I can just pick out the details that I need for I make a new read model to answer tomorrow's question. And I think event sourcing has a sweet spot when it comes to a task-based user interface, because if you have more crowd-based and just save the strategy, you have already at that point kind of lost the intention. What was the user trying to do? But on a task-based user interface, as we have, where they define a new strategy, they take ownership to the strategy, they start and stop that strategy, then you know by the command, you know what intention the user have, and it's easy to make the right domain event, to tell the right story. So a sweet spot there. And time traveling, haven't you ever always wanted that? To be able to travel in time? Unfortunately, we are not able to travel into the future. That would be awesome. But at least with event sourcing, we can travel back in time. Once I was on a project where the users told me that they had some fabrics, and the fabrics had outages, and they told me, we are likely to need to know how many of these outages did we know about 3 months before they actually happened. And those kind of questions is easier to answer in an event source solution. Unlucky for us, we never got around to implement that requirement, because that would have been very fun to do, because we have the pattern that is a good fit for solving that problem. In-memory read models. Those projectors that make the read models, what if every time you restart your application, you just start from the very first event and you loop through them all? Then you can build up the state. You don't need to have it in any database. As I said, the source of truth of your data is in the events. And then you can hold those read models in memory. And I guess this, at first claimed, sounds really silly. Nobody does that. Yeah, we do. Think about it. In the early phase when you are making the solution, my experience is when the user sees something they are asked for us to display to them, they understand what they should have asked us to display to them. So these read models tend to change much more than the write side in the start. And not having the database definition and needed to do anything there makes it faster. And also the read models in memory, it is in memory, so it's really fast. And we have those read models, we have them in production, but we also have read models that started in memory in production. And when the total number of events became too big, well, then we just decided we want to save them. And this is the kind of option I like as an architect. I don't need to do it, don't need to decide, should I ever need to save this information? I can do it when it's needed. And it also helps with distributed solution. And this is a lot about this outbox pattern. I don't know if people know about it, so I will take it just briefly. If you, for instance, should do an API call in a non-event source solution, you will maybe save some information, and you also save that to an outbox that you want to do that API call. For instance, sending that email, just because you can wrap it in a transaction, and then you pull that outbox to call that API that are sending that email. When you do event sourcing, you get this for free, because the event store has a possibility to push out that information. And at least what we are using is Cosmos DB in Azure, but there's a lot of alternatives. If we push it out until we manage to actually call that API. So we get those kind of things for free. And it also helps us with the modular monolith pattern, and that's what we are using most of the time. And again, it's because we have our aggregates that could react to each other, and we have the read model that could also listen to those events, but it doesn't react to them, it's more projecting the information there. But doing that, this is actually out-of-process communication, so it's quite easy to take a part of it and to make it into a separate runnable process, or you could take the read model and actually put that on different data centers if you need. So it's a modular monolith. I was at NDC last year, and there, NDC Oslo, I should say, because that's it's many places, this NDC conferences. And Laila Porter had a good talk on distribute-ready monoliths, as she called it, and it's all about when things are out of process, it's kind of ready to be taken out and distributed. I think it's a good fit for a near real-time user interface. So what do I mean by that? Well, we are pushing out the information to our users. If a trade is done by that algo, they should know it right away, not trying to pull or refresh the browsers, of course. And there's a lot of ways to do this, and you can absolutely do it without doing event sourcing. But I think the hard part, if you're not doing event sourcing, if you have some changes, how do you know what part of the user interface that is actually now changed? That is more explicit in an event source solution, because the read model itself will know, I have been changed now, and it will know exactly what has been changed. And by having these read models, we always do this back-end for front-end pattern, so it's quite one-to-one to where it's used in the user interface. And then it could just push up a message saying, OK, this has been changed. So that's what I mean by it's a good fit for the near real-time user interfaces. And I find it easier to extend. And what I'm thinking about here is that since we have these different events on an aggregate, I find it easier to add a new event that is important for my aggregate than just expanding on the aggregate in general. So it's these building blocks. Also, if we need to display some information, again, it's a new read model. So it is these building blocks that makes it easier to extend and not only enhance your solution. And I think there is a bet here that we don't know is correct or not, but it's that we, hopefully, because it's easier to extend like this, and we have all these building blocks, it will be easier to stay like a system that we are able to maintain over time. But that bet we don't know if we will win. And we get an audit log for free, because time is an important and explicit dimension in your solution. And you will know what have happened and what sequences that happen in. And this gives me what I call debugger heaven. And as I said, being in the software industry for a very long time, I know how it is to have no clue. How did we get to this state? Once I was working, I think I just have been working for a couple of months or something after I was graduated, and it was in an accounting solution, and we had this issue. We had a hole in our transaction numbers. And if you know anything about accounting, that's bad. It's really bad. And I actually used a whole week just to figure out how could I recreate that situation. And finally I found that if I opened this window and I pushed calculate there, and I went in the other window and I pushed calculate and save and did something else there, and I went to the first one and I pushed save, I got that situation. And then I have to convince the business people that that's what they have done. Now, when there's something happening in production, and I'm always stressed when there is an issue in production, my first go-to place is this audit log. And I could see, what? Did that event appear before that one? And then I did that one? It doesn't make sense. But then I know where to start. I know what have happened, what made us into this issue, because the story is there. And that is something I really appreciated all the time, especially since that 1 week of have no clue what is happening here, why did we get to that state? And for our real models, we can even take this stream of events and we can just take a copy of it, and we can literally debug our code that will listen to one event and build up the state. So then you can be a real programmer and really debug your code in your IDE to see what have happened in production. Why did we get that strange state? Oh, it's a nice one. And it's easier to scale parts independently, as I said, since it's out-of-process communication. You can take out the real model, make it your own process, and you can put it on different data centers, or you can have many processes to run out. So it's easy to have this modular monolith as long as you need it or can have it, and then you can do, again, take those options to make it better. Okay, a lot of good parts, but I'm sure you, there are hard parts too. And this one is the one that you should never, ever underestimate. And I think it's one thing that a lot of people talks about. And that is just a new way of building solution. It is a new mindset. And it's often less experience in the team. And if they, in addition, think event sourcing is a bit silly way to build solution, you have a real problem. I think to do event sourcing, you have to embrace those concepts. You have to kind of bad compromise. Partly event sourcing, it doesn't work. You have to embrace it and almost believing that this is a good way to build a solution. Again, that's why it's so important to know if it's a good fit for your problem. But it is much harder to find people knowing event sourcing than find people not knowing event sourcing. And as I said, immutable events, they're hard to correct mistakes. I have to admit it, sometimes I do miss my way of just changing that state. It is a bit tempting, but of course we get the real story in our core of our solution. And I want to mention this because I said so much about those reactors, and I really like them. But the reactors, since it actually reacts to things after it is saved to the database or the event store, it will slow down your solution if you compare it to have everything in memory. But I think it's all about the pain point. For us, for instance, if I ask my users, if it takes 2 minutes from a trade is done on that, by that algo to you can see it in your dashboard, is that okay? They probably will say no. 2 minutes? In trading world, that's a lot of time. But if I ask 2 seconds, is that okay? Well, then the pain point is somewhere between 2 minutes and 2 seconds. So it's all about understanding your use cases again and understanding if is this actually a problem. But since I said so much good about the reactors, I want to highlight this one. Of course, it's out of process, have a lot of good things there, but it also has always this latency that comes with it. And then we have this eventual consistency. Because course, the read models listen to those events and it builds it up. It's not synchronous in the same transaction as the new event is saved. Of course, you can build that. That's possible, but then you don't get the benefit of doing event sourcing. So we avoid that. And of course, the same for the reactors. We could have one process, one code that actually started the strategy and did everything until the algo was running. But what if the external platform was down and we have still not given the answer back to our users? There is trade-off. Everything when we are building solution is trade-off. But it's eventual consistency, and you need to think about that. But for the read models, again, as I already said, I think it's about this pain point. But I also want to challenge everybody to think about what is consistency anyway for your users. Because even sometimes when I read on the internet for read models, it seems to be a big issue. But does a consistent database mean it's good for the user? You see, I have experience here too. I worked in a solution with a huge, enormous database, and it was best in class when it comes to two-phase commit. Everything was strong consistency. And I had the pleasure to have walkthrough with a set of users using our solution, and one of them told me something that has stuck to my mind. She said to me, and this was a Windows application with a lot of windows. She said, when I open this window and look into this table, if someone else updates this information here, I need to do a refresh, and I will see the updates. And then she took up a second window, and she said, when I look at this information, if someone updates it, well, then I need to close that window or open it again. And then she took up the third window, and she said, when I look at the information in this screen and someone updated it, I need to close my application and restart it to see that change. So how she had learned for all those windows, all those rules? Well, being a consistent database doesn't mean it's consistent information for your users. So I just want to challenge that a bit. Those events live forever. And this is one of the things you won't get around it. And it is hard. Because even though we, for our read models, could have them in memory, or if we have a database definition and it changed, we can just scratch that database and build it up again from the first of the events. So we don't need to migrate data or have data schema migration there. We get all the pain points on those events. For those lives forever. So you get versioning on events. I know Laila, that was here before. Today she will talk about some of this based on her title tomorrow. And Greg Young, one of the founders of event sourcing as a concept, actually have written a whole book about versioning in an event source solution. And that is because it is hard. But there is ways to do it, and you can always migrate the events the same way that you migrate your state today. But I think it's good to upfront in your team, if you do event sourcing, to discuss so you know what kind of approach do you want to take for this one. Because we don't have the option to throw away some of those events. We don't want to lose any data, so we have to take the pain point of actually having them changing over time. And this one, making the stream shorter, that was a surprise for me when I started with event sourcing, because I'd done DDD and aggregate design for years, but now there was an additional constraint. And that is because since we source the state of truth of our aggregate instance by looping through the stream of events for that aggregate instance, if your aggregate instance lives forever, then it will be longer and longer and longer. And that isn't a good design. And again, we try to think as they do in accounting. Every year they have a kind of a year close, so they can kind of cut off their stream, and we can start a new one. And that's how we are trying to approach and solve this problem. So there's a way to do this too, but it's important to think about it. And sometimes I really find it hard to both follow how the users are thinking about their business and manage to cut these streams into pieces. And another thing, there's many, many moving parts, and I don't think there is a way around it. So this is just something, I will come back to that at the end of the presentation. It's something that we need to acknowledge. We need to know it's there, and it's a part of the pain that we need to take into account. And it could be harder to see the big picture. I don't think that is because we are doing event sourcing, meaning that we source the state of our aggregates based on the events, but the fact that we are event-driven inside our solution. We get a lot of the same complexity that Laila was talking about when you have event-driven architectures between solutions. And it could be harder, but it's in a way a bit easier because they are all internal events, so we can have causation and correlation that tells us something that this event was triggered based on that one. And this correlate is the stream of the domino effects of events. So we have those patterns to help us, but still it makes things harder. Okay, you can see the list. Clearly you have to go for event sourcing. The list of the good part is much longer than the hard part, of course. The item on the list and the number doesn't matter. It doesn't matter at all. What's matter is for the problem you are solving, how important is the items, the individual items. And of course, this isn't a complete list. I'm sure people working with event sourcing could add more points to it, but I just took the ones that I found is important to think about. And then, as I said, it's all about understanding the pain and the gain for your problem to solve. Okay, I hope you will get this list and maybe think about why you should use event sourcing, but how should you build those event source solutions? Here I have a really good news. All you need is 4 building blocks. And to be honest, all we use is those 4 building blocks, and I find that pretty amazing. And these building blocks, they're on the way to talk about them. I found from a talk by Sebastian von Conrad, so I want to mention him. I think it makes it very clear, and it helps us in our team. We always know what building block we are discussing, because they help us to set the scene for the discussions. So the one is the event store. And as the heart of it, as really basic part, the only thing the event store needs to do, it needs to be able to load event for a stream. And of course, those events need to be in the right sequence. And then you can loop through them to get the state. And then it needs to be able to save events for a stream ID, and by that, appending it to the stream. And this is a good thing. I like to work with the business part of my application. I've never been the one that liked database and that part so much. And when I have a new aggregate now, do you think I need some database logic? I don't. The new events is just new payload. And the new aggregates just have different types of IDs. So I can introduce new aggregates types and new event types in my solution without doing anything to my event store. I like that one. The second building blocks is the writing with command building blocks. So here, I have discussed this already, but I will repeat it because I think this building blocks is kind of the clue here to make it easy to build this solution. So the user does something, we capture that intention in a command, and then you have the aggregate state, and it leads to new events, and those new events update the aggregate state. And I will say some more about the aggregate. When I've been working with non-event source solution, I'm always used to, and this is how we are thinking in DDD, because the aggregate is a way to model our solution. So we read it as a unit. We don't read the one line of the shopping cart. We read the whole shopping cart if that is our aggregate. And we update it as a unit, and we save it as a unit. So that's what I've been used to before, because the aggregate is really the transaction boundaries of our system. So the aggregate are consistent, but between aggregate you have eventual consistency. Also, when you're not doing event sourcing. And this writing with command then, it loads all those events for that aggregate from the event store, and it loops through it and sources the state. And when I've done step 1 and 2 here, that is just what I did before, when I just read my aggregate state. And then, of course, you need to do the stuff you need to do, but here they start to differ, because the result of this is actually new events. Before that was a new aggregate instance or an updated aggregate instance. And what was a bit tricky for my head when I started with event sourcing was the fact that I should never ever update my aggregate instance. Not even when I did this, the command do something to the aggregate. It never updated the aggregate instance directly. It just makes those events, and then it used those events to update the aggregate state. And when you are done that update of the aggregate state, you have not saved your events yet. So you can check, is my aggregate state still valid? Is debit equal credit, if that's the rule, all those invariance rules. And then you save your events. So in my aggregate, what I need to do, I need to let the command do something that lead to those events. And then I need to define, if it's a new event type, I need to define how should that influence my aggregate state. And that is the code bit that I'm using also when I'm building up the aggregate state, when I'm reading it for the database, but also to get to the updated aggregate state that I could check for invariant rules. But it's important when I read the events from the database, but those events are fact. So when they are saved, they are saved. Then I never check the invariant business rules. What if your rules are changing? What if you can't be a gold member until you have bought things for 1,000 euros? And then the business rules change. Now you need to buy things for 2,000 euros. You don't want it to fail when you load your aggregate state. That is fact. You don't need to check it then. It's for the new events that you ensure that you are in a valid state. The third building block is reading by queries. And here you have the read models. So you have an event, and you project it to a read model state. And of course, if this is the very first event that this read model is interested in, that read model state is kind of empty. And then then that leads to an updated read model state. Just as simple as this. This is the pattern for that building block, and we try to make it stay as simple. And of course, in order to do this, we need to listen to those events. As I said, using Cosmos DB, we have something called change feed. Using other event store, you will have something else. The point is here that you have something that push out the events when they happen, and take care of bookmarking. So you don't need to do that yourself. And I love this, that I don't need to hammer anymore. I don't need to ask, has something happened? Has something happened? What is happening here? Of course, there's hammering under the hood, I guess, but you don't need to think about that when you are building these solutions. So the read models, quite easy again, I think. You need to have a place where you actually hold your state. And as I said, small read models have many, not one huge for your application. And then when you do the project event, for each event type, you can define how that event type will update the aggregate state. And I hope you see here how I can extend my read models quite easily, because I just have one place I plug in how should this new event type actually update my read models. And I know I haven't done anything to the functionality for the existing read models, event types that also are updating this same read model. And then we have the reactors. And Sebastian von Conrad, he used to say that that's the cool stuff. And I tend to agree with him. You can say that writing with command handles client commands, so everything the user do through the interface. Read queries, as he called it, instead of read models, handles client reads. And reactors take care of everything that is the rest. And then again, the reactors building blocks, that we know that it's only the reactors that are allowed to do side effects. And we know that the reactors is the one that need to know how to react to events and take care of all those rules whenever this happen, that should happen. The more automation it is, the more of those rules, very, very useful. And it's the same pattern for how we can implement it. You need to create the command from the event. That is how you capture the intention. How are your intention? How do you want to react on that event? And the second step is you need to do something to an aggregate and or actually perform the side effects. So again, if the reactor needs to react to an other event, then it's just to extend this. And we don't have one huge reactor in our solution either. Each aggregate typically has its own. And it also have reactors that listen to outside events. That is also, we use this reactor not just for event sourcing, but also for reacting to the outside events, which makes it really easy for us because it's the same pattern. And as I already said, we can use it to publish outside events too, react to an inside event and make an outside event. So that is how we build event source solution. And the thinking here, and I think again, the mindset for how we are doing event source solutions are important. So the thinking here is that we take all these building blocks, and it's like Lego bricks. You have many of them, typically not many event stores, but of the rest, and you assemble them in different ways to build your business application. And then I want to point out that event sourcing, I already said, is a complex arrangement, and I don't think there's a way around that. Of course it isn't. But it has to be a complex arrangement of simple part. Because if not, you get a complex arrangement of complex part. I guess that's the road to a distributed monolith and a big ball of mud. And the way we try to do this is to always remind ourselves in my team about these building blocks. Just look at them. They are really simple. If my read models need to know that this event was before that one and after that one, and last year I got this event, I don't have a simple part. The read model state need to have enough information that all it needs is one new event and it could update its state. So it is a building block that is deterministic, and so is the writing with command building blocks. And you have to make them small and simple. But then it's fun. Then the different pieces sing together and make crazy good applications, with some bugs and issues, of course. But then you have the debugger heaven. I just want to say, event storming, Alberto Brandolino is at least in Europe this year and had a brain workshop earlier this week. It's a perfect technique. I like it so much. And when you do event sourcing, it's even better. And I'm approaching the end here now, but I want to end with some comments on digitalization and event sourcing. Because in my company, in Equinor, of course we want automation. And here I think the reactors, it's a building block from heaven. Whenever this happens, that should happen. But the automation is just one part of it. We don't want the automation to live on its own. We want to empower our users. The traders I'm working with, they can start on algo, but they are still responsible for the trades that algo is doing. They need to stay on top of things. And here I find the read models as the perfect building blocks. So my personal bet is that I will be continuing making business application by doing event sourcing, just because I bet it will be a good fit for the problems they want to have solved tomorrow too. And by that, I want to thank you, everybody, for listening, and have a nice rest of the conference.